Okay. Then we should get started. Welcome to your MetroStyle app video and audio part 2. So has everybody heard the first part of this talk? So just by show of hands, everybody? Yeah, so most people. Okay. So I'll make that assumption that you've heard what Gabe said. Yeah, my name is Daniel Schneider, and together with my colleague Tim Onders, we'd like to show you some of the more advanced multimedia features available to you as you build your MetroStyle media apps. So Tim and I both work in the multimedia platform team where we built the audio and video experience in Windows 8, or help build it, rather. And that includes more advanced features like Stereo 3D and streaming and transcoding and also stuff that Gabe's already showed you. And it also includes the APIs that are being used to offer the functionality off to you, the developers. Right. I'm actually very excited to be working on Windows 8 and to be talking to you about Windows 8 today because I'm actually a managed code person. Right. So I've worked on or with or on managed code languages for all of my career. And with Windows 8, we're actually making the full power of Windows available to the managed code developer. And I think that's a very exciting thing to be working on and to be talking about. Just before we get started, I would do just a quick poll. And we already kind of saw that there are mainly C# developers in the audience. So just let's get started. So who are the JavaScript, who would consider themselves more or less a JavaScript person? Okay, Gabe, thank you. Okay. And who would be a C# developer, has done so in the past? Yeah, okay. So how many C++ developers do we have in the audience? All right, yes. That was kind of unexpected. Okay, and who of these, now let's get drill a little bit deeper. So who of those, or maybe also the others, have done MF components in the past? So who has done an MF component? Thank you. Okay, so you have a few people that actually have implemented MF Media Foundation, I should say, components. And yeah, you'll see that there's actually a great way in the media space for those who know how to do MF and the managed code developers to work together and share code or one to be using the code of the other. Okay. So where's my clicker here? There are really three things that I would like you to take away from this talk today. First of all, using the media functionality for MetroStyle apps or when you build your MetroStyle apps is really easy. So we've actually invested quite some time in making those APIs, as we did with all the APIs, easy to use and very consistent to use. And I think there's been a lot of talk about that in the keynote, in the big picture sessions yesterday. And so really you get rich functionality exposed to you through some very simple to use APIs. And you're actually able to leverage the full power of Windows as you use those APIs. So media is no exception. We're making the full power of the platform, including hardware acceleration, full hardware support available to you as you use our components. And the third point I would like you to take away is that if you need to, and this is where the MF developers come in, you can actually extend the media platform with native components. And then in your actually managed apps, this is C# or JavaScript app, you'll be able to use the MF component that was built for you or by you and use it just like any other platform component that you find on the system. So the agenda that I have here is actually somewhat organized around the points that I wanted to make. First of all, I'll talk a little bit about media playback in the HTML environment. So this is basically what HTML5 gives you, what the standard gives you. And I'll have a little demo and show you how powerful that actually is already. And then we'll talk about your MetroStyle app and how you actually can take it to the next level by leveraging Windows functionality. And here we have three areas. We have the use of media from anywhere, so different locations. And we'll do a little coding demo there. And then we'll enhance the media or how you can enhance the media experience using playback in the background, and also using playback buttons, player buttons on media buttons on remote controls and other hardware. And then the third area is all about extending the platform with custom components. And I'm only going to talk about how you actually do that from the JavaScript perspective or the managed code perspective, the C# perspective. I won't be able to talk or won't be talking to you about how you actually implement those functionalities. There's another talk that I'll point you to where you should go if you're actually planning on building your own components that extend the media platform. So, without further ado, let's dive into the architecture here. So Gabe has showed you this architecture already, and it's a little more extended here. I've got a few more components that I need to cover. But at the very top, you see, obviously, your Metro Style app that you're building, and that could be in C#. In this case, this slide is geared to JavaScript. And then for the playback and preview functionality, you use the audio and video tags. These are defined in the W3C standard, or draft as it is still. And so these functionalities give you basic playback and preview, and we've augmented these with some additional attributes and methods that are only available to you as you build your Metro Style app. So those are not available in the browser. However, the main functionality, the body of the functionality, is actually available in the browser. And then you have this vast amount of functionality which is exposed to you through the Windows runtime. So if you want to capture transcode, do streaming, extensibility protection, media control, and a few others, you use those APIs. And if you've got an HTML app, obviously you use them through JavaScript. In a XAML app through C# or VB. So what's important to understand about the architecture that we're showing here is that it is really the same architecture so the same functionality for the different languages. So down there we have the Media Foundation, which, as I pointed out, can be extended with your own functionalities. And below the Media Foundation, we have DirectX and the Windows Audio Session APIs, which are available to the Media Foundation to do its work, but also to the C++ apps, or the functionality actually that you're plugging into the Media Foundation, or your just native apps that you're building. So this is the slide that Gabe already showed to you. Just quickly to reiterate, the main work in the HTML5 standard palette of media is done, or the source for basically, or how you leverage functionality in an HTML environment for media is the audio and video tag, right? So they're full HTML elements, which means that they can be fully styled through CSS. They can be accessed through JavaScript. They're full first-class citizens of the DOM. So you can access them through the DOM through get element by ID and all those. You can select them through class selectors and so on and so forth. So that's already very handy, and it's very well integrated into the fully integrated into the spec. And you have a bunch of methods available to you and functions and attributes to configure your components, like play, pause, load the content you can have here. You can access the different audio tracks, and you can get the current time, the duration, and so on. So that's not very surprising. Neither is this. These are the events that in this case, the HTML video tag emits as it is doing its work. So you can see, I don't want to go into detail here, but you can see they can actually keep pretty close tabs on what the video element is doing as it's doing its work. And so if you want to render custom UI on top of it, this is giving you all the affordances that you need. So I would like to dive into a quick demo. So which machine? Is it this one? 4. So I would like to show you just a simple player. So this is obviously a Metro style app. And we have a little application here that does HTML5 video playback. So this app here, or this portion of the app, only uses the functionality that is also available in the browser. So I could make this app without any problems run, just like with the same functionality in the browser. So I can play back the
This is channel 1.
Video here.
This is channel 1.
I'll just mute the audio for now. And as I seek around here, so obviously you see as it plays, you see time updates here. So we get four updates per second as the media is being played back. So that allows you, for example, to do a progress indicator or to synchronize other events with the media as it plays back. And as I'm seeking here, you get additional events like seeked and then seeking and then seeked. So you see that it's seeking, and then once it's seeked, it's giving you a timer update again. So it'll let you know when it's back to actually playing content. So obviously, I have the ability to pause and play from the outside to these controls here. I can easily go to full screen. It's just CSS, right? So all I'm doing here is applying a CSS style in order to stretch the video all across the whole screen. So there's no magic about that either. So a little more advanced is the feature here when I'm trying to, or when
This is channel 1.
If you listen to the current audio,
this is channel 1.
Very enticing.
This is channel 1.
So this is an English channel.
This is channel
English
1.
Audio channel, and then I can switch that to Hindi.
ये दूसरा channel है.
And we'll try to get better audio tracks in the
这是
future.
频道3。
But so this is Chinese and
To jest
Polish, which
kanał
is
czwarty.
reflective of the team that's been working on this
To jest
feature.
kanał 4.
So,
To jest kanał 4.
so this is a HTML5 feature as well. And another one, which is maybe a little less obvious, is I can do little bookmarks here. So I can go on the video and set bookmarks here by clicking on this button. So, and then if I click back on one of those bookmarks, it'll just jump to this position. So obviously it's somehow extracting frames from the current video as it plays and then putting them somewhere here in the area for me to click on. Right? So how do we do this? Where's my clicker going there? How does this work? So let me first explain the in-band audio track selection. So if you look at the video track at the signature, and again, this is all HTML W3C functionality that you can do in IE10 as well as in other HTML5 browsers. So the audio track attribute exposes the multiple media tracks that are in the content that is currently loaded up in the video tag. So as long as you package your content according to the MP4 spec with multiple tracks or respectively the ASF spec, then we'll pick that up, or Windows will pick that up and expose it to you through the audio tracks attribute. And this is the code. I hope this is big enough for you to see. This is the code that I was using here in this sample app to extract or to populate the language select box. So first of all, we're getting the video element from the DOM, and then we're iterating just in a for loop. We're iterating over the length of this audio tracks list, and then we can get the language here from the current track that we're selecting, but we could also get the ID or the kind or the label if those are populated in your content from the audio tracks attribute here. And then we'll check which one of these is actually the enabled audio track, and then use that as the selected version or the selected option in the list box. And here is how we're actually reacting to somebody changing the selection. Again, we go over all the audio tracks on that current content on the video tag. And if the current track that we're going through actually corresponds to the current selection, then we'll enable that one, otherwise we'll disable, right? So we're disabling all others but the one that's selected. Okay, no rocket science, obviously. But it fits on one page, and it's a fairly advanced feature, one might think at least. So the other thing we did was we did those little bookmarks where we were pulling out of the video as it was playing the current frame and positioned it somewhere else on the page for us to click on. That was done by using Canvas. So Canvas is a pixel-oriented drawing surface defined in HTML5 in the standard. And there's this method called drawImage that allows you to draw on that canvas and provide a video as an input, which will then just pull the current frame from the video and draw it. And here again is the code that did that work. Here we're taking, again, the video element out of the DOM. This is the area, the div that accommodates, just basically you think of it as a box, that will accommodate the bookmarks as we capture them. And then we're creating a canvas element in the DOM and append that canvas to the bookmarks area. We give it the appropriate height and width, and then we draw. We get the drawing context from the canvas. Think of it as a brush. And using that brush, we draw an image on the canvas, and the source of the drawing operation is the video that we had extracted. So it's neatly integrated. The canvas and the video tag work pretty well together here. And here we're just memorizing the current time where this all happened on the video. And then as the user clicks on the canvas element, we set the actual current time at that point in time to the current time that it had when we captured the bookmark. So really both of these samples just fit each on one page. So as I said, simple APIs allow you to use the powerful functionality of the platform, even in an HTML-only environment. So let me tell you. Okay, so as I said, so far this was all something that you could also run in your browser. Now let's take a look at some of the stuff that you can do that you cannot do in the browser that will allow you to actually leverage the full power of Windows beyond browser functionality. So first of all, use media from anywhere. So Gabe already spoke about this a little bit. In a MetroStyle app, you can not only use media or play media back that comes back from a web server or a streaming server, but you can also access content that is, for example, in the packaged with your app or that is local on the file system of the user. And a few more things like home group and so on. So what I would like to drill into a little bit more is the use of media from the local file system. So, or the local libraries in this case. So you have the storage picker, and Gabe talked about this a bit. So he's also shown you some code around this. The storage pickers, you can think of them as a file open dialog in a MetroStyle environment. So if you want the user to pick one file and then you want to play that back in your media, in your video tag, then that's what you want to use. If, on the other hand, you want to use, or you actually want to visualize the user's video library inside of your app, then there are obviously multiple ways, but there's one nice and efficient way that gives you the MetroStyle UI for free, and that's using the list view control. And in XAML, it's actually called the grid view, just to confuse everybody. But in the JavaScript world, it's the list view control that can have a list view or a grid, a list layout or a grid layout. And the third thing that was also touched upon by Gabe was the file properties that should be mentioned. And you actually get access to the normal file properties, like the name that you would expect or the path. But you can also get access to rich properties like the thumbnail. And for a video, that is actually a frame that's captured from the video from Windows to the system. So it's a very complex operation that you get exposed to that API. And then there are actually media-related special APIs, like the release year of a movie or the artist of an album for a track that you can access through these file APIs. So I would like to drill down a little bit deeper on the list view API by giving you a quick coding demo in Visual Studio. So I'm going to start off with an empty project. I'm going to launch Visual Studio first. So I'm going to start off with a new project. I'll use a JavaScript navigation application as a template. And I hope the demo gremlins aren't going to haunt me today. So if I start off with this, and I don't know, has anyone actually started using their tablets and building JavaScript apps? Just show of hands. You've been, oh, not many. So they're all still in their boxes?
No, we're just not using JavaScript.
Okay, so they're not using JavaScript. Okay, so you all have built C# apps so far? Who's built C# apps since yesterday? Okay, we have a few. Okay, so then this is news to you. Well, maybe you've seen it yesterday in the big picture sessions. So this is basically what I get presented with if I just use this this navigation template. So it already looks quite a bit like what you've seen in many of the sessions and many of the apps. So as where it says content goes here, this is where I actually want to see a list of my videos that are in my folder, in my videos folder. And let me just show you those. Okay. So these are the videos that are currently in my videos folder. And those I want to see show up in my Metro style app, but in a Metro style UI, obviously. Okay, so I'll close this. So the first thing I need to do, and that was also made clear in the sessions yesterday, is if you want to access a file system, you have to declare the capability to do so. So the first thing I'm doing is I'll go to the Apex manifest here and go to the capability section and click video library access, right? So done. So now I have access, and my app can now use the library and access the files that are in there, in my video library. So the second thing, what I'm going to do is I'll add some styles, and I'm being lazy, so I add them in my HTML here, that allow me to render the content nicely and give the tiles the appropriate size. And then what I'm going to do now is, here where it says content goes here, I'm going to inject a div. And a div that had already been used for the bookmark, a div is actually just a block-based area in an HTML document. So it doesn't have a particular attribute to it other than that it kind of flows with the other content surrounding it, unless you give it different styling. But so this div is just a container for me now. This container will later hold the list view element, the list view component. So and then we go into JavaScript, and as a C# developer, this is somewhat the code behind for the HTML that we have here. And there's three things that we have to do. The first thing is, in this initialization function that we're calling, or that we'll be calling, the first thing is we need to create a file query. So we start off with you look here, you start off, up there, sorry, with the video library. And then we compile a few query options that, for example, filter, we only want MP4 and WMV files here, and also tell the query that we actually want recursively all subfolders. And then, based on the library folder here, we'll create that query with these options. So that's the first step. The second step is we need a data source. The data source will kind of be the link between the file query that we just created and the list view that will actually visualize the content on the screen. So the data source here is really configured with one interesting attribute here, which is the thumbnail size that we want. We say we want videos view. That means that is just the largest thumbnails that we can come up with. And then we create this data source using the file query as a parameter and the options that we've created. And then we have the third part here to the whole story, which is the actual list view that we're creating. The list view as an input gets a data source that we just created and an item renderer. So again, the C# people in the audience, you know all about data binding and renderers and all of that. This is, for everybody else, this is basically the entity. In this case, it'll actually be a function, but it could also be a data binding template that will render one element, right? So that's responsible for rendering one item on the screen. And then all items, like each file, in this case, video, will be rendered one by one. And here you can actually see that we're giving it a layout, and we're using grid layout rather than list layout. So it comes up as a grid. And in the last step here, we're actually creating the list view control, and we're associating it with this div element that we had created in the beginning. So if you remember, like the empty shell that we created where the content should go, this is how we're associating it with the list view. And then we pass in some options, the options that we had created up there. So I still owe you the storage renderer. So that is the item template, if you wish. In this case, it's actually a function, but we could also use markup, right? So just to keep it simpler, we have one function here. It gets passed in an item, and it then accesses the item through just normal dot notation. Item.data.thumbnail will give you the source, the path to that, or to actually the object that represents the thumbnail. And then we're turning that actually into a URL by means of create object or URL. Okay, so last thing we have to do is to actually wire this up to make sure this code actually gets called. Oops. What's happening? Okay, and then fingers crossed. Okay. Okay, took us 5 minutes. But it's a full Metro UI type of representation of the user's video library, right? And you get some of the animations are already in there. So if I click something, I get this this effect where it's kind of being pushed in, and there's some mouse over in this case. What's also in there by default, and that's actually very valuable and otherwise pretty hard work, is asynchronicity. So this thing actually came up, and let me show you this maybe again. So we can show it from here. You can see it's coming up immediately, and the thumbnails get loaded later. And the reason why it's taken a little while to load is that the Windows indexer hasn't groveled them yet and saved them with the files or in the index. But in this case, it's very good, so I can show you, because the app is immediately functional, and it's immediately responsive. So the user can immediately interact with it and scroll through it, and as the thumbnails are still being loaded from the disk, and asynchronously. And as they show up, the data source will report it up to the list view, and then the list view will redraw that area. So very powerful control. There's actually a whole talk on just the list view. And so if you're interested, it's, wow. I think it's 210. Yeah, it's 210. Builds data-driven collections and list apps using list view in HTML5. So if you're planning on using that control, highly recommended because it's very, very powerful. Obviously, you'll learn how to select. You can set selection on. You can single selection, multiple selection, and so on and so forth. And it works well with the file system, but it also works equally well with data that you load over the network. So just to recap, go back to the slides. If you want to use local libraries, and if you just want to have the user pick something, use the pickers. So if you just need a path or one file from the user. If you actually want to access and visualize the libraries, the list view control gives you a lot of functionality, and it's already very close to where you want to be in terms of MetroStyle UI with only minimal work to do. If you're using list view control, and so as with everything where you're actually accessing the file system itself, make sure you declare the right library capabilities, or else you get a access denied exception, and you'll find out soon. So let's talk about how you can further extend your MetroStyle Media app through further making use of the Windows capabilities. So the next thing I would like to point out is background media. So background media is actually managed by Windows for you. So what you're doing in your app is you categorize your audio or your video tag as a certain category of media or a category of sound source or audio source. And then Windows will decide for you whether your audio can be heard while it's in the background, or whether some other app came along that, which then means that your app will get muted, right? And there's certain priorities in there. For example, real-time communication supersedes media playback. And in order for you to make it easier to have it, to make it easier for you to actually build a good user experience around this, we've introduced the notion of media focus. So media focus really means if your app has media focus, then it can be heard. And it's playing back media, it can be heard. And as it is being muted by Windows, you will lose media focus. And there's a side effect of that. You've seen yesterday, in abundance, I think, the suspension, so how apps are actually being suspended as they move to the background. So if your app is moved to the background, after 5 seconds, normally it'll get suspended, unless you take special precautions that I'm going to tell you. So as long as you have media focus, you will be on the Keep Alive list for Windows. So we won't suspend you. And as you're losing focus, you'll be removed from that list. So that's when you know whether you're about to, whether you have a long lifespan or not. So I like to show that quickly. So I have an app here. So the first media here is not categorized at all. So it's just a default. This is the default behavior of Windows. Can we get the audio? For an audio tag. And as I move to another app, which is not the, let's kill this guy. So if I come back to that app, it can be heard again, unless we have HDMI issues. Okay, and now if you look at the counter, now we're at like 32. And if I move off the screen and then come back, it just was muted, right? So it didn't stop playing, it was just muted. So that is the default behavior. If you just write an audio tag or a video tag or a media element in XAML or it'll behave that way unless you categorize it. So the other one we've categorized as media, right? So this is same track. Now as I move to the background, you can launch other apps. Keeps playing, right? So the interesting part is obviously what happens when another app comes along that also wants to play. Well, that depends on the category. So if it's media, then the second media wins over the first one in this case. And the one in the background that you saw on the side here lost focus. And we used that focus lost event in this case to pause. So we're not using any resources on the system. If you can't hear it, there's no point. Right? And as we come back to that app, we receive focus again, and the app can play again. So what happens with another category, like alert? This is different. The alert, maybe you hear this, this Outlook alert. It's not you don't have any appointment. So the alert plays, but it attenuates the media that's playing in the background. Right? And as I stop the alert, the media comes back. So the app didn't have to know about this because it was still continuing to play. Right? So the background app is still rolling. So how does this work in code? So first of all, what are the touch points that you in the architecture that I've already shown you? What are the touch points that have to do with playback in the background? Interestingly, I can't, and well, we'll see whether that comes back. So first of all, we have the MS Audio category attribute. That's one of those attributes that are not available in the browser. They're prefaced with MS, and they're only available to you as you develop MetroStyle apps. So if you set the category to the appropriate value, that's the first thing you need to do. If you want to do playback in the background, it would have to be media, narration, or communication, as I'll show you on the next slide. And then, and this should actually be the media control. I can't even see this here. The media control API. Here is where you would listen to media focus events. And this was kind of somehow lost on me. Obviously, white on white is not very well visible. So these are the two areas. These are the categories that you have available to you as you set this category value. As I said, I'm not going to go through all of them. I just want to point out that the ones in blue are the ones that enable you to do background audio. Right? So if you use those, then that will enable background audio for your current audio-video tag or media element, respectively. What's interesting about communications is that it has also side effects on two other attributes of the media tags. MS Realtime, which will so setting into communication will actually also, as a side effect, set MS Realtime to true, which will set your pipeline up for low latency. And it says the MS audio device type will be set to communication. That means that the audio will come out of if the user has a headset connected, that will basically out of the default communication device. And usually if you plug in a headset, that will automatically become your default communication device. Right. There's actually a talk about that. That's 778, Media Fundamentals of a Communications App. So if you're interested in how to build a communications app, that's the talk to go to. And they also drill deeper on the low latency feature. So there's another thing that I haven't talked about yet about background audio that you have to set. That means otherwise your app will get suspended. So you have to set the in the package manifest, you have to set the background task to type audio. And that is the first thing that Windows looks at if you're becoming a candidate for suspension. We're looking at your manifest, or basically the information from the manifest, and look whether you actually have a background task somewhere. And if that background task is audio, then we'll start looking at the media element and the sessions that you have going on there. And if there are any of those that are in there of the currently playing and of those 3 background types, then you can live on. Otherwise, you'll be suspended. Then, obviously, setting that attribute is very straightforward. You just set the MS Audio category to, in this case, media. Works on the audio and video tag the same way. You can also create the elements dynamically. So here's obviously it's happening in markup. You can do that dynamically too, but you have to make sure that you set the attribute first and then set the source. And you have to set the attribute through the DOM APIs rather than the direct dot notation. They're not exposed through the dot notation. So just in case, and then you want to listen to the media focus events. And here, as it says, as I said, the one that wasn't visible on the far right, the Windows Media Devices media control is the namespace or the object that gives you the opportunity to add those event listeners and listen to the media lost, media received focus. And I use that in the app, in the demo app, to pause the stream and then to restart the stream as the playback, as we regained focus. Right? And here, really, the story behind this is if the user can't hear the audio that you're playing, you shouldn't be using up resources, right? You should be streaming like for example, if it's an HD video that you're streaming over the network and the user can't even hear it, let alone see it, you should be considerate of the resources that you're using. You get better reviews for your apps if you do that. And while you're actually while you're listening to events, suspending and resuming are equally important because as you suspend, you should persist your state. You know, as you've seen, apps get swiped through pretty quickly, and users don't want to kind of navigate back to the same place that they've been before. And that actually goes for media apps just like for any other app. So if I'm playing back media, a certain media from some location, the user will want to, as he brings up the app, will usually want to be in the same place where he left off. So the suspending event is the last time you have a chance to run and save any of your state. After that, you'll just be terminated. You might not, because if we have enough memory and if you don't need to get, if your system isn't overloaded or anything, then nothing might happen. But if you want to save something, that's your last chance, because you won't be called again. So just to reiterate, to enable background audio, declare the background task type audio in your Apex manifest. Set the MS Audio category according to the type that you're playing back, narration, communication, or most notably media, probably in most cases. And then listen to the media focus events. Somewhat related are the media buttons. So just because they're actually from the same API, they're exposed to the media control API as well. So if people have like these remote controls, or also with media buttons on them, also like a keyboard like this has media buttons on it. People have headsets that have media buttons on them, and all those buttons you can catch through this API. So if there's a play pause button on it, then the play pause handler, the play pause toggle selected will fire as the user clicks it. And that will happen regardless of whether your app is in the foreground or whether it's in the background. It will get many apps will notify, like if you have like 5 apps that are concurrently playing media, they all get notified of the play and the pause and those functionality. So it's really easy to use, and you get like a bunch of devices unified through this API. So we recommend to use those APIs and get happier customers that way. So I think I got to talk a little faster. So the next topic is slightly more advanced. That's Stereo 3D. So the Windows, the video tag can just fine playback 3D content. And you can query the system through the display properties on whether it supports Stereo 3D playback. And then if it does, then you can go to your content on the video element and check whether the content is currently loaded in the video element and whether that supports 3D or not. And if it does, then you can just switch the rendering mode over from mono to stereo. And we won't do that explicitly because we don't know whether the user actually has their glasses on or not. But as you can see, it's pretty much 3 lines of code, and then I'll show you just a quick sample of that. And for the 3D content, has anybody done 3D content? Anybody who's got an exposure? Oh, okay, wow. Okay, sorry to tell you that the stereo support is not present in the Windows Developer Preview, but it will come online later. So we rely on H.264 SCI messages for the metadata. So if you encode your 3D content, use that format, and then we'll pick that up and expose the functionality to you in the app. So this takes us to the, this is the short slide that I said, really 3 lines of code, checking for whether stereo is enabled, and then checking whether actually on the video that we're handling, the stereo 3D, whether it is stereo 3D content that we're dealing with, and then we switch it over to stereo and play. So this takes me to the last area of this talk in terms of how you can actually take your Metro style app to the next level. And this is how by extending the Windows Media Platform with custom functionality. So this is where the MF native components come in. And as I said, in order to use this functionality, you don't need to know anything about MF or C++. Just as you want to build the plugins themselves. But if you have a plugin, you can just use it, just like any other component. So here's the fundamental model of the extensibility, and Gabe already mentioned this quite a bit. I'll just drill a little bit deeper. So the fundamental here is that your extensions, your DLLs, your native MF components that your app is using, they ship with your app. So you'll be packaging them with your app, and they will be local to your app. So that means your app will have access to your custom format that you're bringing along, but no other app on the system, right? So that is a good thing because, first of all, your users will be confidently installing and uninstalling apps. So they won't be scared that they might be interfere, that app that is bringing its own codecs is going to interfere with some other app that might be using a similar or the same codec. And it also, for you, it means that you have less to worry about because you know that your app is kind of sandboxed. So it knows what environment it's dealing with, which is exactly the out-of-the-box environment for Windows, and it doesn't have to be concerned about other components from other apps interfering with it. So here's the way in our architecture on how you actually extend the custom format. So say as you extend the media platform with a custom format. So say you want to bring in a foo format. Say maybe smooth streaming, for example. And you want to bring in this format, then you'll have a byte stream handler, first of all, and audio video source, which is like a DMUX that is splitting up the file format into streams, into video and audio streams. And you'll have to, first of all, register this DLL that contains those 2 native components in your extension section of the Apex manifest. So that's the first thing. So register that thing. And you'll give it actually, it'll also reference the name of the activatable class ID in there. And you'll see that in a second, what that is in more detail. Then you'll take that name, that activatable class ID, and associate it with a file name extension or a content type, and a content type, I should say. And you do that in JavaScript in your app, or in C# in your app, right? So you go to the extensibility manager, and it's just the same C# or JavaScript. You go to the extensibility manager, and the extensibility manager offers the functionality to register a byte stream handler for a certain extension, file name extension, or and content type. And then, in the third step, you just fire up a video tag or a media element, set the source to a content that is actually serving up, or a URL that is serving up that content of yours in your custom format, and then the content will play. So here's, just to make it clear, here is the source. So this is the XML of the package Apex manifest. And here we're registering the SSMF plugin m.dll. And we're actually saying, hey, inside this DLL, I know there is a bytestream handler that can be invoked through this activatable class ID. Right. And then, when we're in JavaScript, and again, this is the same in C#, we go and get the windows.media extensions manager, and then we call the register bytestream handler method on it, and we register this activatable class ID and associate it with a file name extension and a content type. So anything text/XML that gets served off on a server, which I would set on my video tag, will get now offered to this bytestream handler. And the bytestream handler can actually decline it, right? So I could say, oh, I can't, this is actually some other XML that I don't understand, but and then we'll try the next one that is mapping to the same. And then the third step is actually setting up our video tag here with the source that is pointing to this content. Okay, so now this is the Gabe already told you that we had some connectivity issues here, so this is the demo that requires connectivity. So I hope it works. So this is actually smooth streaming using this very mechanism that we just showed you. I should probably switch to the right machine. Okay. Just fire this up again. Yeah, so this is smooth streaming content. Do we have audio? Does it have audio too? Yeah, the Silverlight developers among you might know this movie or clip. It's been on Experience Smooth Streaming for quite some time. So what's interesting here is, obviously, we've extended the system with a custom format, but it's making full use of hardware acceleration. So you can see that the smooth streaming player here, to decode 720p video, is using around 5% of CPU on a mid-range machine, Core i5 CPU. Obviously, this is using our hardware accelerated H.264 codec in this case. Okay. So, smooth streaming. We will make a smooth streaming SDK for Windows Metro-style apps available. So you'll be able to do what I just did here. And then you can use that. You can use that in your C# apps, or in your JavaScript apps, or in your C++ apps, or in your Visual Basic apps, right? By the mechanism that I described to you. So we'll be supporting on-demand streaming and live streaming, as well as player-ready protection here. And if you want to read more about IIS, there's a link for you. So the extensibility manager, what we just did, we extended the system with the bytestream handler. There are actually other ways you can extend the system. So all those things down there that you saw in the pipeline in the architecture diagram can be replaced by you. So you can plug in your own audio encoder or decoder. So the encoder is mainly obviously for transcoding scenarios, as well as video encoders and decoders. And you can also, instead of doing a bytestream handler, you can use a scheme handler, which is triggering then off of the first, in the URL, you've got the HTTP colon or MMS colon or RTSP colon. So of that area, you can just basically trigger off of that rather than of the file name extension or the byte, the content type. Content protection is also pluggable by the same mechanism that we've talked about. And usually the content protection system will actually expose to you additional functionality through WinRT. So if you have a license acquisition, for example, there will be a separate an API that is exposed to you through the content protection system rather than through Windows, right? That's the beauty of the Windows runtime, that other components can actually plug in there and expose their functionality uniformly into all the other languages as well. So, and we'll provide an implementation of PlayReady for Windows 8 as well. And we'll feature the WMDRM content, PlayReady content, of course, but also WMDRM content, and much in the same way as we do that today for Silverlight content. That means you can use your existing content. You don't have to re-encode your libraries or re-encrypt your libraries, but you will have to run. So PlayReady can play back the content or decrypt the content if there's a PlayReady license on the system, which means that you need to run a PlayReady license server in order to crack the content. OK, so this takes us to the last section of this talk. You're going to have to order for that. And Tim's setting up here the next demo, which is fun. Going to be a fun demo, hopefully. Audio and video effects are just actually using the same extensibility mechanism as the custom formats that we just talked about. They're IMF media transforms in the, to the MF folks in the crowd. And they take in samples and put out samples. And what they can also do is they can expose an additional API through the Windows runtime again in order to receive, so that the app can actually talk to that effect. So, and an example would be if I want to visualize audio like through an FFT transform, then I need the peak data from that effect. So the effect will just pass through the data, but it will report to me the values. So we'll just, and this is again, same mechanism. You register in the manifest, and then you use the MS insert video effect and MS insert audio effect attributes to add the effect to the pipeline. So we've built a little game that is, oh, I'm already losing here, that is actually using these lamps, and it's detecting the position of light on the screen. And now I can, whoops, yeah, I can play with Tim this game. So do some power play here. I'm totally frying you here. So. Right. So I think we'll get very rich with this, won't we, Tim? So, yeah. So. I'd buy that for 99 cents. Would you? Thank you. OK. So, I mean, you can see the coordinate. I don't know how well you can read it there, and it's really, so you can read the coordinates up there in the corner. We got a frame rate there, which basically says how many callbacks we get, and if anybody thought that doing that kind of stuff wouldn't be possible because you get 30 frames per second out of this, we're calling into JavaScript 30 times per second here, and this is absolutely no problem, right? And then we get those coordinates here and the size of the object. So you can see up there in the upper right corner, because we're mirroring, we're at 0, 0, and down there in the corner we're at 1,007, 1,000. Well, lucky. By 768. OK. So that's how that one works. We'll have some details on slides. Oh, thank you. Thank you, Tim. Thank you very much. So, and this is really quick to just explain, and to make sure that there is no misunderstanding on how this did work. So we have a video tag here that is actually showing the camera capture. And on top of the video tag, we have a scalable vector graphics element, which is just it's a surface where in HTML5 you can draw geometrical objects and move them around. And down there we have the camera that is sending video frames to the object recognizer, and that is written in C++, right? And the object recognizer is an effect that we've introduced into the pipeline, and that is just analyzing the frames as they pass through and is looking for those light blobs there, right? And then it's sending the video frames completely unchanged through the system, through the pipeline, but it's reporting to the game control, which is written in JavaScript. It's reporting the coordinates of the object that we've detected. So we get if we have two lamps, we get two objects reported, and where they are at and approximately how big they are. And then we use those coordinates to set the records in the game, and everything else is just collision detection between the objects and the balls, right? So it's really simple. And the way this was created is actually, I can't code C++ to save my life, right? So I had to go and find somebody who can, and it's not very hard if you work in Windows. So, one of our developers was willing to help me in exchange for a crate of beer. And so he basically built this object recognizer video off of a spec that I created, just like a half a page. And yeah, so I could have built something completely different. I could have built like a drawing game, right, where I'm just drawing stuff on the screen, because all I'm getting up is from the recognizer is where is an object and how big is it? Which coordinates, how big is it? So I think it's a great example of how you decouple between the managed code developer that is working down in the MF innards and is reporting something up to somebody who's really kind of that doesn't have a lot of C++ or exposure at all. Okay, and with that, I would like to recap. So we showed you a few things, and I said I wanted to have you take away 3 things from this session. First of all, that using the media in MetroStyle apps is easy. And I've shown you a bunch of code samples. Most of them fit on one page. They were in JavaScript. Had they been in C#, they wouldn't have been any longer. And we have very rich controls that enable you to actually do that in such short time and so little code, which is the audio control, the video control, but also controls like Canvas and the list view control that we've used. Obviously, we have full accessibility of the Windows functionality, including the hardware acceleration, and we've seen that in multiple places. And we've seen the extensibility of the platform through plugging in smooth streaming and using this codec, this effect that we used to play this little game. And with that, I'd like to close. Point to related sessions that we have. So if you're interested in how actually to build this in detail, the MF component itself, I highly recommend 783T, which is extending the media platform using input and output, so processing and plugins. And also, certainly for the C# audience here, integrating stunning media experience in XAML, which is app 788T. That is this talk, probably some overlap with this talk, but it'll be all about XAML. So all the samples will be in XAML, and some of you will probably feel very much at home there. Here's some housekeeping. There's some decks that some white papers. So if you download the slides, please go to the forums if you have any questions later. But Tim and I will also be in the platform area in the expo right after this. So we'll probably be here around for another like 10, 15 minutes, and then we'll move over there where you can actually ask us questions. And we'll be also there at the Ask the Expert session tomorrow. And with that, I'd like to thank you very much. Please provide some feedback. Thank you.